Okay, lesson 2. We're starting off with Newton's laws. So these first slides are going to be just talking about the laws. We're going to jump in here first and then keep building. So Newton's first law. Some of these things, again, should sound familiar to you. Really should have heard of Newton's laws by now. Even if you can't remember which is which, we need to memorize that in this class. But you should have heard them before. So Newton's first law is an object at rest tends to stay at rest. An object in motion tends to stay in motion, which means traveling in a straight line. When we say stay in motion, we mean in constant motion. So the direction is not changing and the magnitude of its motion is not changing. Both of those things mean stay in constant motion. If one or the other is changing, yes, then we're being acted upon by an unbalanced force. Either the direction or the magnitude of my motion can change, and that means that I'm being acted upon by an unbalanced force. We're going to clarify unbalanced force later. Now, Newton's first law is sometimes called the principle of inertia, or the law of inertia. Inertia is defined as the amount of object's resistance to change in velocity. This property of inertia is quantified by its mass, i.e., heavier objects have greater inertia. Now, to clarify here, inertia is not something we're going to have a formula for. When we say that it's quantified by its mass, all that means is that, that thing is heavier, okay, it has more inertia. It's kind of like saying, oh, that object is purple. That object has more inertia. It's not like a formula or anything. We can just talk about that object having more inertia, which means a greater resistance to change in motion. That's all. There's no formula for it. But we can say that inertia is directly proportional to mass. So if mass is doubled, then inertia is doubled, etc. But again, the kind of weird thing, though, is that inertia is not a force. It's a property of an object. It's not really a quantity. Again, when we say property of an object, it's like saying, oh, that thing is green or that thing is blue. That thing has a lot of inertia. There's no formula for it. We just talk about it as a property of an object. So I want you guys to pause the video here and go ahead and create this note card for Newton's first law. And again, we sometimes call it the law of inertia, being defined in there as a resistance to change in motion. Okay, let's go ahead and keep going. So talking about mass, we have to be careful here. In physics, we can't use mass and weight interchangeably. They actually mean very different things in physics. So mass is how much matter is contained in an object. This stays constant wherever you are. It's measured in kilograms. So if I'm on the moon, or if I'm in Jupiter, if I'm in the middle of space, yeah, the matter that's contained in the object doesn't change. Yeah, that matter moves from place to place and is going to be the same. However, weight in physics is something different. Weight is, it's a lot to write, the magnitude of the gravitational force exerted on an object. So whenever I say weight, I'm talking about the force of gravity. And we're going to talk more about forces in the next lesson, which equals mass times gravity. And again, we're going to talk a lot more about this. And again, gravity we know to be the 10 meters per second, right? So if my mass is, well, we'll talk about that here. Backtracking, it's measured in newtons, and again, we're going to talk much more about forces later. But it changes depending on what the acceleration of gravity is. Have you ever heard that you weigh less on the moon? That's what this is talking about, right? You would feel lighter on the moon, versus if you went to Jupiter, that has a much greater force of gravity, you would actually feel heavier. Yeah. So weight is what you actually feel on your body, depending on the acceleration of gravity of where you're at. So it says, what is the weight of an object with a mass of 20 kilograms? Well, once again, when we talk about weight, you have to immediately think force of gravity. And force of gravity equals the mass of an object times, again, G is just 10, right? Whenever you see G, we mean 10. They just use G sometimes. So this is 20 times 10. So this is 200. And again, we're going to talk about more about forces in the next lesson, newtons. So 200 newtons is the weight of an object. Once again, if they ever ask for weight, it's in newtons. Mass is kilograms. So check your understanding here. Read very carefully. It says if your mass is 75 kilograms on Earth, What is your mass on the moon? Go back up and reread this. If our mass is 75 kilograms on Earth, what is it on the moon? Well, mass doesn't change depending on where you're at, so it is still 75 kilograms. Again, mass is how much matter is contained in an object, not the weight that you feel due to gravity. And we're going to watch this video in class, so we'll come back to that later. And I'm going to show those to you guys in class as well. Okay, so 2 more slides we're doing here. 1 more slide and then one more note card. So key points of Newton's first law. In order to change the motion of an object, you need an unbalanced force acting on it, right? So what that means is if you want to speed it up or slow it down, you need forces to do that. And that's going to lead us into Newton's second law. Now, if all the forces are balanced, which means I can push one way, but if I push equally back the other way, yeah, that's a balanced force. Yeah, there's no one way or another. Yeah, if I'm pushing equally in 2 directions, they cancel out. What we expect to see is a constant velocity. Now, 0 velocity is still constant, but remember, I could be going 5 meters per second, and if I have a balanced force acting on me, it's not going to change, actually, right? Constant velocity changes to our motion. If I have a constant velocity, that's going to stay the same. Now, again, with this, don't get confused with the idea that you need a force to move. You don't. Again, if I throw a ball in space, it's going to keep going. It's going to keep moving in a straight line. Yeah, no forces are acting on it, but it will keep moving. Unless a force acts on it, then the motion will change. So once more, once an object is moving, it will keep moving unless there's something else acting on it. So I want you to go ahead and make this note card. This is Newton's second law, which is a result of that. Yeah, we need a force to cause an acceleration. Acceleration is a change in our motion, right? So go ahead and create this note card, and then that'll be the end of the video. We'll continue more tomorrow.